In this video, I'm going to do a few examples of setting up interrupts and timers and periodic interrupts on the MSP 432 embedded system hardware. Just a couple quick examples, and I will do my best to explain them as we go. The first example is to write a snippet of code that will set the priority to be 1 for timer A1. This doesn't actually matter for the solution of this problem, but timer A1 is interrupt 10. So if I actually go and look at the different interrupts that the MSP 432 has, I should see that that corresponds to NVIC IPR2 or NVIC IP2. So the bits I need to set are the bits 23 to 21 on that one. So that's what I need to do, is set the bits 23 to 21 on NVIC IP2. The first building block is to keep the bits that we don't want to touch. So I can do that by taking the existing data that's on NVIC IP2, that register, and ANDing it with F, meaning all ones everywhere that I don't want to change. So that would be for the first 8 bits, next 8 bits. Then we're going to be changing the third set of 8 bits, and then 2 more after that would get Fs. So essentially what that's going to do is wipe the bits we care about messing with and leave everything else the same. Then we need to set the priority to be 1 on bits 23 to 21. In binary, the 2 hex bits of interest are located, if I'm going 23 to 21, 23 is the most significant bit. 21 is 2 down from that, and then I've got more. So if I write that in hex, that corresponds to 0x20. Now, if I were to write this out as a full 32-bit hex value, I would write this as follows: 0x00200000, and I'm going to OR that to be able to set it to be 1 for NVIC IP2. So that's what that looks like. So the final snippet of code is this: is NVIC, then I point to IP2. It's equal to the existing value ANDed with Fs everywhere I don't want to mess up the bits, and then I just OR and set to get 1 for my priority by using that hex value there. In the next example, we want to write a snippet of code to enable the interrupt 38 on the NVIC or nested vector interrupt controller. The 38th interrupt is obviously the one we want to activate. The problem is that the register ISER, which is what we need to adjust, is only 32 bits wide. So the ISER register 0 goes from 0 to 31. If I'm going to the 38th interrupt, that means that I need to move to the next ISER. So it would be ISER 1 to get to the 38th. That's what we would do. Then I take 38 minus 31. So 31 is the highest number that ISER 0 can do. And you'll see when I take 38 minus 31, I get 7. And I count up from 0. So the 0th bit is the bit that corresponds with 0 is the first bit. So as I move up, that means that bit 6, which is the 7th bit from the right, that's the one that we need to set. And if I write that in hex, that's 0x40. And so essentially all I have to do is I need to set NVIC ISER1 to be 0x40. That corresponds to where I need it to be. I could write out more zeros because remember, this is a 32-bit value, but I'm only in the first section, so I can use this. It should work just fine. So that's my final answer. All right, example 3. You have timer A2 set up for a periodic interrupt. Write the ISR, which acknowledges the interrupts and sets a variable called flag1 to be 1. Our solution here is if we want to work with timer A2, we need to write a IRQ handler, an interrupt service routine, that is going to correspond to that. In that interrupt service routine, I need to acknowledge and clear the interrupt itself, and then I'm going to set some global variable which is called flag1. Turns out the solution's pretty easy. We simply create the function ta2 underscore 0 underscore IRQ handler that links directly to the interrupt of interest. In order to acknowledge, I'm going to clear the cctl0 register, because that's the register where I reset the timer, and then I'm going to set the variable. So that's a relatively simple thing, and really the timer's already set up. Every time that I trigger the interrupt, I need to clear that interrupt has happened, so that way it starts counting again, and I'm able to continue timing and interrupt the system at a specific frequency. Final example, it's a little bit longer, so this video is coming off of what I would do in class, a actual lecture about edge triggered interrupts, and I want in this example to rewrite one of the functions from that class, but for a different port 2 pin 3 with a rising edge. We assume there's already a pull down resistor connected to the port, so I don't need to set that up internally in the system, and let's assume the priority is 2. So let's just look at this edge trigger initialization code. So this is what was shown in that lecture. I don't have a video for that, but here's what was shown. In this, what I'm doing is I have falling edges 4. That's just a variable that is really global that I'm going to be setting at another time. If I were doing an IRQ handler, I would probably adjust falling edges value in that. Then I set up P1 select 0 to get pin 1.4, so that's the bit 4 or the 5th total bit of the register for P1 select 0 select 1. To get GPIO, I need to make everything 0 there. To get the direction, since it's input, I need 0, so I'm using and equal not to clear. Then we, in this case, it's enabling the pull resistors. We don't need to do that because in our rewriting, we're assuming those resistors are already connected externally. Then you'll see the P1 out. That's also for the pull-up resistors. Again, those two lines we're going to ignore in the solution because that already exists externally based on the problem statement. Then I need to adjust the interrupt register. So IES, it allows me to set which edge, falling versus rising edge. I also have the flag for the interrupt. That's the IFG register. I want to clear that flag. Then I need to arm the interrupt. Then I need to set the priority. And then lastly, I just need to enable the correct interrupt. And I'll use the enable interrupts command. So this is what we're going to try to mimic in our code. So first thing we're going to do is remember we want port 2 pin 3. Pin 3 is the 4th pin, and so the hex value associated with that is 0x08. So we'll start in this function edge trigger init. We're going to set rising edges to 4, same as we had before. And then we're going to set it up for GPIO input. We're not going to mess with the resistor enable. We're not going to set the output to get the correct pull up or pull down. We're assuming this already is true. Then I need to adjust the IES to get rising edge. In the previous, you had a falling edge, and so you were using or equals to set it to be 1. To get a rising edge, we want it to be a 0. Then in the next line, what I'll do is I'll clear the flag for the interrupt to make sure that we're not holding on to an old interrupt flag. We want to make sure that the flag is cleared so it doesn't kick me right to the interrupt service routine. Next, we'll enable interrupt using the IE register. And then really the last part we need is to be able to set the correct priority. you'll notice that this is NVIC IPR 9, or NVIC pointing to the IP register number 9. And so if you look down here, I'm pointing there just like I did in the previous example. I am writing a 1 or anding it with 1 everywhere that I don't want to adjust. And then I'm going to OR for priority 2. Priority 2 tends to be 40 in hex value, again because we only adjust the 3 most significant bits. So if I'm writing 2 to there, it looks like 0100, which is 4 in hex. That's where the 4 comes from. And then the next thing I need to do is I need to actually set the ISER. So if I go back several slides, let's see if I can actually make that happen quickly. If I go back several slides to this one, this is the enable. So I need to enable the correct one. So again, let's return. Here I want to do the 36th interrupt. So I need the 5th bit counting from 0. That is bit 4. Looks like of hex value of 0x10. That gives me the enable for that interrupt. And then lastly, I just write the enable interrupts command, and I should be able to initialize this edge triggered interrupt on a rising edge using this code. That's all for now. There are more examples of this, and for students who are in my class, they're going to work through some examples, but I wanted to give you walk through several examples to make sure that you're on your way for setting up interrupts, periodic interrupts, using timers, all of that kind of stuff. Hope you enjoyed the video. Thanks for watching.